Get started. Hi, everyone. Welcome. Thank you all for being here today. My name is James Saryawini. I am a software development engineer at Amazon Web Services. I work on the Python SDK as well as the AWS command line interface, which is what I'm going to be talking about today. And we're going to look at not only how to install and configure the new CLI, but we're also going to walk through the major features of the CLI, as well as walking through an example of how to set up a static blog using the CLI. But before we get into that, what is the AWS command line interface? It's a relatively new tool. We just had our 1.0 release this past September, and it's a unified tool to manage your AWS services. And unified is key here. By unified, I mean that you have one tool that has one installation process and one configuration process, and access to over 24 AWS services. Now, it hasn't always been this way. Historically, each service team has provided their own CLI, so you'd have a separate install and configuration process per CLI, and there might be different prerequisites, Java or Ruby. And as the number of services grew, we realized we had the opportunity to consolidate and unify the command line so that you had a consistent experience across all of the different services. And that's what this new AWS command line interface provides. So getting set up with the new CLI is very straightforward. I'm going to cover the installation and configuration process here. We support all of the major platforms, so Windows, Mac, Linux. And on Windows, you have an MSI installer available for you. So you download the MSI, you run through the steps, and we'll set up the appropriate environment variables. So you just have an AWS command available for you. We also provide a bundled installer. So a bundled installer has all the dependencies you need to install the CLI. And the way that works is you download it, you unzip it, and there's an install script. Now, by default, it'll go in your home directory. There are command line options that allow you to change where to install it or whether you want to create a symlink to somewhere that's on your path. And we'll look at an example of this in a few minutes. So the other option for installing the CLI is pip. So the CLI is written in Python and is a Python package. So if there's any Python developers out there or anyone familiar with pip, you can use that to install the CLI. You run pip install -- upgrade AWS CLI, and you'll get the latest version of the CLI. You might have to use sudo depending on how you have pip set up. And if you're on a Linux distribution, generally, if you don't have pip available, you can run sudo apt-get install python-pip or sudo yum install python-pip, and then you can use that to install the CLI. So that's installation. For configuration, probably the most important part is how you manage your credentials. And we have 3 options available for you. Probably the easiest is if you're on an EC2 instance and you launch it with an IAM role, we'll automatically detect that. And you don't have to do anything to configure your credentials. So you're all set. Just install the CLI, and you're ready to go. We also provide environment variables. So you can export these variables into your environment as a way to also set your credentials. And the last option is a config file. So there's a .aws/config file that you would provide these 2 values here, and we'll see what the specific syntax looks like for the config file. But if you do want to use the config file to manage your credentials, we provide an easier way to get started, and that's this configure command. So once you install the CLI, you'll have an AWS executable, and you run AWS configure, and it will prompt you for some values here, your access key, your secret key, and then these 2 other options we'll look at a little bit later. And once you've done that, it will, if the config file does not exist, we will create it for you. We will then write out the values for whatever you've entered, and you're all set. You can also use the configure command to update existing values. So if you want to change a value and you don't want to open it in an editor, you can use this AWS configure command, the current values presented in the brackets, and then you just hit enter to accept the current value, or you enter a new value. And also, if you have comments or existing formatting in your config file, we won't touch any of that. So you can use this to safely update any existing values in your configuration file. Now, if you do want to create that config file by hand, which is perfectly fine, it would look like this. You would have a default section. You would then have the AWS access key ID and the AWS secret access key, as well as region and output if you want. So you notice there's this default section. So you might be wondering, are there other sections you can provide? Yes, and one of the most popular ones is to configure additional profiles. So you might imagine I have a testing profile and a production profile, and then I can have different sections in there with different credentials, different regions, and then when I run a command, I can say what profile to use. So if you want to have all of those in a single config file, you can do that. And we'll see an example of that later. So that is installation and configuration, and we're now ready to run services. So I want to actually show how to do this in a terminal here. I know I went through that pretty quickly. So I'm at a terminal, and I want to install the CLI. And we'll walk through these 2 steps we just looked at. So the first thing I do, and I'm going to show the bundled installer version. So the first thing we do, we download the bundled installer. And once this is downloaded, we'll unzip it. And then we'll look at those other options I mentioned about where to install the CLI to. So we'll unzip it, go into this directory. And so there's these other options here, an install directory and a bin location. So if you want to put it in, say, user local AWS or somewhere else, you can do that. And then if you want to create a symlink to, say, user bin AWS or something else on your path, you can do that. And so in this case, I'll just say, let's install to demo CLI just for the purposes of this demo. And so it requires no network access at this point. Everything it needs is self-contained. You do need Python, though. And we support Python 2.6, 2.7, and 3.3. So now that we've installed it, you can run version. And it's in a self-contained directory. So everything's in this temp/demo CLI. So if I want to uninstall it, I just can remove that directory. It doesn't put anything outside of that directory. And at this point, you can create a symlink or add it to your path. Or what I'm going to do is just probably create an alias. So I have the CLI installed, and I want to configure credentials. I'll use a config file. And again, I have this pre-populated. But you'd enter your access key, your secret key, region name. I'm going to use US West 2 here. And then the default output format, I don't have one. And that's it. That is getting installed and configured with the new CLI. So now we can run a command. And we'll go back to the terminal in a second, but I want to talk about the structure of a command. So here's an example. This is to describe all of the instances you have in a particular region. And the syntax here, you start with AWS. So we only install a single executable, which is AWS. And then you use the service name and the operation name. And you'll see this output here, which we'll talk about in a second. But this general structure is the same across all the services. So if you wanted to run, say, the list users command for IAM, it would be AWS IAM list-users. It's that same general structure. For arguments, this is an example of import key pair. So if I have a public key, an SSH key, and I want to import it, we use the long option name, so --key-name, and then the value. And then here we have the public key material. And this is the first thing I want to point out. You see this file : //. And this is a general pattern that applies to all the values in the CLI, that you can provide a file : / prefix for any value. And what we'll do is open that file, read the contents of that file, and use that as the value for that parameter. So in this case, I'm saying the public key material is in this file location. So this might be good for things that are naturally suited to a file, or if you have long or really complex input parameters, say an IAM policy or something, you can use that. This also applies to HTTP and HTTPS. So in this case, we'll retrieve the contents at that URL and then use that value as a parameter value. So that's the first feature I wanted to go over. Next, when you're using the CLI, a natural question is, how do I know what arguments to use? Where do I find that information? And so you have 2 options really available for you. First one is to just use help. So when you do that, you can add help to the end of any command, and we'll pull up a man page for you that has the name, the description, all the options, and their documentation. And in many cases, you'll have an example, too, that shows specifically how to use this command. If you prefer HTML version, we have the exact same content rendered as HTML and hosted on our docs site, so docs.aws.amazon.com. And you can read the contents there. So if you prefer that, you can use the man page, or you can use the HTML docs. And this applies to any tier of the command. So you can run AWS service operation help, and that'll give you the examples we just looked at. If you run AWS service help, that will give you a list of all the available operations. And then if you just run AWS help, it'll give you a list of all of the available services, as well as top-level commands like the configure command we just looked at. The second option is tab completion. So we support tab completion for a number of different shells. And for example, with Bash, you would run this on the terminal, or you could add this to your Bash RC, or however you want to set that up. And we will auto-complete service names, operation names, as well as parameter values. So tab completion is something you can use as well to figure out what options are available for you. So I want to go back to that original command we looked at, the describe instances command. And this is actually what your output might look like once you have a few instances running. And this is this JSON output, so you can see there's reservations that have instances and a number of different key value pairs. And while JSON output is useful, so it can be useful in certain contexts if you're piping into something with a full-fledged JSON parser or tools that can manipulate JSON, you can use that. However, we do support multiple output formats. So there's the JSON output, which is the default. We also have a table output. And table output is good for interactive browsing. So if you want to just run a command interactively and see that output in a way that's maybe easier to visually parse, you have that option. And also, we have a text output. And this is similar to the existing CLIs, if you're familiar with that output. And this is useful if you want to pipe to other text tools, sed or grep or awk, tools like that. And the way you configure this, that was, first of all, the output configuration value we saw a few slides ago. But also, when you're running a command, you can use the -- output and give any of these output formats. And so I talked about the different output formats, but I didn't really go over what they look like. I think that's a little bit easier to show in the terminal. So I'm going to start with a command here, describe regions. And so this is the default JSON output. You can see you have regions that has an endpoint and a region name, and that's the basic structure of this output. Now, if I run the same command with a table output, you can see it's the same information, just structured a little differently. That makes it easier to see that you have an endpoint column, you have a region name, and then the same data as before. And we can look at what text output should look like. You'll notice you'll have an uppercase identifier followed by tab-separated columns. It's the same information, the endpoint as well as the region name. And so this makes it useful, for example, if you wanted to get all the region names and maybe iterate over them. So for this region, I won't actually run the command, but let's say I wanted to describe your instances in a region. Oops. And then maybe also see all the running instances. So you could do something like that, and that would just give you a list of all of your instances in all the regions, as an example. But if you notice here, we're grabbing a particular column out of this response. And while you can use tools like grep, or in this case cut, and that works fine, another option that we provide is a query option. And so I'm going to show this in the terminal before we switch back to the slides. And the way that works is you run AWS EC2 describe. And there's a query option. And what this does, it allows you to give an expression that says what type of output you want to select. So that same thing that we just saw, I can say regions, say I want all of them, and then get the region name. And it'll give me that same output. What's nice is this is independent of your output format. So this is JSON output. I can still say that I want text output and do the same thing as before, where I iterate over the regions and call a command with a region argument. And so this was a simpler example with describe regions. If we look at what we were looking at in the slides, describe instances, you have a much larger output. And even with text output, you could perhaps, maybe if you wanted to grab the instance ID, you could say instances. And so you get your instance IDs. But again, using that query syntax, I can say something like grab all the reservations, the instances, and the instance ID. And it's the same output. Now, what's nice about this is the query syntax, or the query syntax actually supports more than this. I'll give you a few more examples. Let's say that I also wanted to select the instance ID, maybe the public DNS name, and whether or not it's running. So in this case, you'll have tab-separated output that has the exact columns you want. And again, independent of the output format. So maybe I want to see that a little bit easier visually. So I can use table output. And if you notice, I don't have column names here, so there is a syntax for that if you wanted to provide explicit column names. Maybe I call this ID, and then host name, and then maybe the state. And so you'll have something like that. So that is using the query option to be able to select the exact output you want. That makes it easier to script, even if you're using text output, or just to create tables that are a little bit easier for you to visually parse. So let's cover some of that syntax we just saw. So this was that first example. You have the regions. And we're saying regions is a list. You can see how it's a list in the JSON in the left. And we're selecting all the elements. And for each of those elements, grab the region name. And so you'll get the output on the right. And then we also looked at something like this, where you have the reservations, instances, and then we're going to grab two columns, the instance ID and the state.name. And you'll get the output on the right. And then also that table syntax. So that's where you can specify a key name and then a state, and they'll actually use that as the column name. And again, these are independent of the output format. So if you wanted this as JSON output, you can still have this as well as text output. So I didn't cover all of the syntax here. This is just an example of some of the other things you can do. You can go into nested hashes, index into an array. There's OR expressions, and then those two versions of the multi-select, as well as the wildcards here. So the feature here is you can use -- query to create the exact output you want. We use a library called JamesPath. There's the link there at the bottom, and it has a full specification in grammar that really talks about the details of what you can do with this query syntax. I want to go back to something that I did earlier in the demo. When I was looking at the running instances, I had this -- filters, and then I had this value here. And I didn't really go over it, and I want to go over it now. If we look at the help for this, we'll see that we have two versions here, a shorthand syntax and a JSON syntax. And you notice that they're expressing the same values and the same content here. There's a name that takes a string, and then values, which is a list. And you can actually specify either version that you want. So in this case, this is useful maybe if you're typing it on the command line interactively. And this would be great perhaps if you wanted to put them in a file or run them through a JSON validator to make sure you have the correct syntax. But they're exactly equivalent. There's no difference. It's your preference which one you want to use. So you can use shorthand syntax to specify parameter values. These are these non-scalar parameter values. So the next thing I want to cover is large responses. So let's say I run a command, and I get something conceptually like this. I have 100,000 records, and I want to work with them. That's how you would think of working with a large response. You just have a lot of data. But a lot of times what happens with the services is you'll get something like this, where you'll get a single page of responses, and you'll have this little marker that says there's more results. The results have been truncated. If you want more results, send that same request, but with a token, and we'll know to give you that next page of response. And so in your code, you would say something like, while it's being truncated, grab the next page of results until you get to the page on the end that has no truncation. But really, you want to think of it conceptually as just a single large response, and then something else should handle how to transparently make that efficient and grab the next pages while there are some. Because the services operate in terms of a page size and a next token. And sometimes these parameters are different names per services, next token or next marker, or sometimes it's implied as the last element in an array. And what the CLI provides is transparent pagination. So what this means is, by default, if you want all the results, you don't have to do anything. You don't have to worry about there being results being truncated and you didn't grab the next page. We'll grab all the results for you. And instead of thinking in terms of page sizes, you think in terms of max items. So you just say, I want 3,500 elements, and we'll figure out what that means in terms of grabbing responses until we have the exact amount you asked for. And we'll also give you a token as well. So if you do want to grab the next page of results, you can use this -- starting token. And it's just this opaque blob that you get back, and you'll just send that in the next request. And so that lets you not have to worry about pagination. And I do want to mention that if you do want those raw pages, there is a -- no paginate option if you want to disable this feature. But you can use starting token and max items to paginate results. Otherwise, the pagination happens transparently for you. So I want to recap so far what we've looked at. We've looked at the file : // That's a way to specify parameter values in a file. We've also looked at how to get help, so the man pages as well as the HTML documentation. We looked at tab completion and how you can enable that in the various shells. And we covered the JSON, the table, and the text output formats, as well as how to use the -- query option to select the exact field you want out of response using a James path expression. And then we looked at shorthand syntax as an alternative to the JSON syntax. And finally, we just looked at pagination and how it's handled transparently for you, or if you do want to paginate, it's in terms of the maximum number of items rather than the pages. So I want to switch gears here and talk about setting up a static blog with Amazon S3. And so we'll just use some of the features we just looked at to accomplish this task. And the basic steps here, we're going to create the blog locally, sync it to Amazon S3, use AWS Identity and Access Management to restrict access for a user to just push content to this blog, and then look at using Amazon Route 53 to set up a DNS name for this blog. And if you're not familiar with a static blog, I'll go over that real quickly. So generally what this means is I have some sort of static blog generator. I'm using a Python one called Pelican, but there are other ones such as Octopress and a number of others, where I write content locally and say this is a sample post showing how to create a static blog. You can render the content, and you can look at that content locally. So for example, this is what it might look like as an HTML version. And you notice this is running on localhost. And so you want to look at how do we actually get that up and push to a public site. And that's what we're going to look at here. So to do this, so the first thing here, we're going to use the S3 command. And this S3 command is going to be used to first make a bucket. So the MB command is to make a bucket. And then there's this website command, and that allows you to specify an index document and basically get a bucket website configuration set up. So next, we want to create a user that has access only to the static blog. And what this means is that we want to ensure that it can push content and essentially manipulate anything in this bucket, but it can't do anything else. To do that, we're going to look at the IAM service. So this is a 3-step process. We create the user, we give it an access key, we give it credentials, and then we put a specific policy that says what that user can do. So we're going to create a user, call it static blog. You'll get this response back. And once we've done that, to create the credentials, we'll say create an access key and use that same username. And you'll see there's the secret access key and the access key ID. And now that we've done that, we can say what permissions this user has. And you'll see this file : // so that's one of the features we looked at previously. And in this file has a policy that says that essentially can do anything to this bucket here. Now, once we've created this, we want to know, how can I tell the CLI about this new user? We have a new set of credentials, potentially a new region or different configuration options. How do we configure the CLI for this? And this is what I was talking about previously with profiles. So I can run the AWS configure command with a -- profile and a profile name. And it will ask me those same 4 questions we saw earlier: the access key, secret key, and then the region and output. And it will write out a new section in your config file with this information. And if you do want to manipulate this by hand, which is perfectly fine, you would just create a new section in that config file. It would have profile and then the profile name followed by these values here. So at this point, we've told the CLI how to use this new user. We want to now, whenever we run commands, make sure that we're using that profile. And so this is one option here. I'm going to go over the S3 sync command. The parts of this command are that we're saying sync from the local directory to this bucket name. That's actually the host name. That's a short version. It should be www.reinventcliblogdemo.com. And we're saying that we want public read, so anyone has access to read this content. We want to delete anything that's on the remote end that's not locally. So if I delete a file locally and then sync, and that file was in the remote location, we'll delete that so that it matches exactly what's on your local file system. And then this profile argument, this is where we tell the CLI to use that profile we just created. So you can add this to any command, -- profile static blog, or you can also export a environment variable that's AWS default profile with underscores. And then that way you don't have to set it for every command you run. So I want to cover what Amazon S3 Sync does. And essentially what it does is it starts at the top. So on the left, we have our local file system. And on the right, we have the contents in S3. And we'll go through those contents in order and figure out if there's any differences between the files. So in this diagram, you might imagine the first file is an example of something that's changed. The next one might be an example of something that was added. And then maybe the last one is something that was removed. So what we do now is once we detect what those lists, what that list of changes are, as soon as we figure those out, we'll add them to a queue. And this happens all in a pipeline. So we don't read the contents of the S3 bucket all into memory. We're doing this as we get pages back. And once we figure that out, we figure out a change, add it to a queue, and then we have worker threads here that will perform these operations in parallel. And what's nice about this is that this might be an example of what the task queue looks like. And it could be doing any number of operations in parallel at the same time, since with syncing, these are independent operations. You can imagine it might add a small file, delete a file. And in the case of large files, we automatically detect that, and we'll split them into smaller chunks, and then upload those chunks in parallel using the multi-part upload API. And this is all happening concurrently, which means that you have a very efficient sync process. So you can use this S3 sync command to sync new or changed files. The files are uploaded in parallel, individual files, and then large files are split into chunks and also uploaded in parallel. And this final part, Amazon Route 53. So we want to be able to go to www.reinventcliblogdemo.com and go there for the blog content. And to do this, we'll look at the Route 53 command. So we just create a new hosted zone with the host name here. And we'll get those name servers at the bottom. And that's where you would go to your DNS provider and enter those values for the name servers. And then here, we're going to use the change resource record sets command. And we're going to look at what the contents of that change batch file is. And all we're doing here is just creating an alias to that S3 bucket. So it would just say that we're creating an alias with that DNS name at the bottom, and the hosted zone ID is for the region that we're in. In this case, it was US West 2. And at that point, we would have everything we need to be able to try out this static blog. So an example of what this looks like is, let's say that so I make a change, and I render that content. And this is that command we were looking at earlier. I'm just going to run the sync command. It'll figure out what's changed, upload them to S3 in parallel. And then I can go to CLI blog demo, and we see that that change here is public. So at this point, I have this workflow where I make the changes, render them locally, make sure they look OK, and then just run that sync command to push that content up. And then you'll have a static blog set up with the CLI. OK. So finally, I want to cover some additional topics. These are some topics that I won't go into too much detail, but I think are interesting and worth exploring if you're interested. The first one is Bodo Core. So the CLI uses a library called Bodo Core under the hood. And this is it's essentially responsible for the request and the response part of the commands. And if you notice, each of the services are specified in a JSON file. And what's nice about that is, for example, with ec2.json, it declaratively describes what that service is. So it'll have things like the API version, the signature version. But also, it has operations, and then it has a list of operations with the exact input and output. And so this makes it very easy to stay up to date with the latest service changes. Bodo Core is also data-driven in the sense that it has things like retry configuration. So if you're curious what a particular retry policy is for a service, you could look at this file and say, this is an example of DynamoDB, that you're going to retry up to 10 times, have an exponential delay, so 0.052 to the x, or to the number of attempts. And this policy applies whenever you have a service error code of this and a status code of 400. And also that pagination was all data-driven as well. And the last topic here is plugins. So with plugins, this is something that if you're a Python developer, you can essentially extend any part of the CLI with new functionality using this plugin architecture. In fact, some of the examples we saw previously were actually written as plugins that we felt were valuable enough to include with the default install. So that shorthand syntax, the configure command, so you can add new top-level commands or sub-commands with the CLI. They're all written as plugins, built-in plugins. But you can also write third-party plugins that people can install and enhance the behavior of the CLI, maybe a new output format or something like that. And so if you're interested in that, the only caveat is that it is in a developer preview. So while the CLI is a 1.0 release or is a full supported release, the plugin interface is subject to change. So just something to keep in mind. So some next steps. I encourage everyone to check out the code. So we're on GitHub. All of this is open source. There's the AWS org, and Bodo Core is under github.com/Bodo. Feel free to file issues on GitHub, or if you have feature requests, you can also file them on GitHub. You can ask questions on our forums. And also, we will be at the Developer Lounge today at 1:30 and for Python questions, but feel free for CLI as well. And then the CLI is also at 3:30. And that's it. Encourage you all to give your feedback on the presentation, and thank you all again for coming.